Hello everyone, welcome back to our debugging course. In this demo, we are going to explore our project. Okay, how the project structure and what are the logics involved there. Okay, let's start with the project count. So in this event scheduler solution, we have three projects. Okay, okay. One is event scheduler. This is the main application. Second one is EventScheduler.Data. This is the project that we use for our accessing our database, data related stuff. Okay, and the third one is our EventScheduler.Services. Okay, this is one we help us to deal with the data access. So for an example, so EventScheduler.Data deal with our database, right? So it will help to communicate between data. Okay, so for an example, here we define our models or entities. Okay, and the migration here and the DB context here. All right, so this is the project contain our data access layer. Okay, that will access the data from the database. Okay, and it will contain the entities. Okay, and DB context where we define our entities and give the structure how the database should be. So we are giving instruction to entity framework how the database should be based on our models or entities. Okay, and another one thing is, so let's see, normally when we think about a enterprise level application, we will have data access layer, uh, application layer, business layer, service layer. There will be different kind of layers, so it is not mandatory to have these layers. Okay, it depends on different use cases, project structure or architecture. So that's the main point we need to consider in this course. In this project, we talk about the basic structure. So event scheduler.data will deal with the database and it will return the data, and we can consume the data directly in the controller. So there is a possibility that we can directly consume the data inside our controller. Okay, data logic can be happen, but the best practice is we need to consume the data from a service layer. Okay, that one is the third project, event scheduler services. That means data access layer, that event scheduler.data will deal with the database and it will return the data. That data can be consumed by the controller from the data access service layer, this one. So this will deal with the database and return the data. That data will be handled by the services that will be consumed by controllers. Okay, so let's start from scheduler.data because we coming from the database. Then let's see, yesterday we talked, class we talk about database. So our project is depends on database dependency. So we talk about how to handle the database using the entity framework. So when we add migration, it will update the database schema, and when we run the update database command, it will update the database according to the updated schema, right? And we talk about the in memory as well, in memory database that is used for runtime database also. That means when you run the application, when we connect to the in-memory database, all the data will be accessed in the RAM. Then it will fetch quickly rather than connecting to external database, or it may be a local one or hosted one. So in memory for temporary, so when running time it will consume. All right, but in here we are going to use a local DB, an external one. So not we are going to use in memory. Okay, So entity framework core will help us to update our database schema and the database. Okay, so we have connected to our Microsoft SQL Server local one. So since our application we use Mac OS, we have used Docker image to um, install a SQL Server, and we have connected to that SQL Server instance image through the Docker, and we have connected it successfully. Now we have updated the database through the entity framework core, and now the database part is done. Now let's see how this code converted to a database. So entity framework core, it's a code first approach that we are using here. Whatever the concept that we have defined here will be converted into a database. So migration we saw, so I will explain every part of each project. So dependencies, obviously we use .NET 8, and imports the SDK, so standard development kit packages included, but we don't need to much worry about this. Okay, yeah, so it contains assemblies, other packages. So migration that we use for update database, and the models, sometimes we call it as entities, because entities models may be different. Some scenario, let's see, it's a small idea. So when we deal with the database, we call it as entities. They are that will be converted into database. So database tables, and model in the one, when the data comes from the database, if we want to display the data into the front end, we use models. Sometimes we call it as DTO, data to object. So we convert the data to a front end object and display there. Okay, therefore our projects contain entities that will deal with the database, that will convert it to a database table, and once the data is received to application, we need to show something to our front end that will maybe a data to object, DTO, that can be models. So that is another section that we learn later in different course. Yeah, that's one part. Other than that, yeah, let's discuss about the entities first now. So entities now deal with the database and get the data. If you see here, application user, right, it contains collection of events, and it's identity user. We will use for Microsoft Entity Framework core identity, so that will give us the login. Let me show you that. At identity, so it's give us a identity for our application, so it's kind of authentication where we can log in as a user. Okay, so at entity framework store, application DB context, default token provider, that there will be a JWT based token that gives us a token to validate the actual user, and so that identity comes from this application user. Okay, that identity. Okay, all right. So okay, actually we don't need to go more deeper because it's a errand debugging host. Events, it's another entity, so it contains participants and speakers, obviously, and it gives other properties. GUID, it's a unique unduplicatable ID key. For particular project it will be unique, and name, description, start, and location, all the other fields, properties, and it can be nullable of these other details. And we have dependencies here: virtual application user, and participants and speakers. Okay, so participants, so it's open mostly, participant details, and the event link with the participants, so it can be not null. Without events there is no participants, that's what it says. But without participant, event can be exist. If no one is coming, then event can happen, but no participant. But without events, no one will come, right? Okay, schedules. So schedule, we use the schedule of the event. So that can be that link to event and speaker link to an event, right? Without event there won't be any speaker, and usual properties for each entity. Obviously that will convert it to a database table at the end when we run we already did this, right? DB sets events, participants, schedules, and keep some readability. Events, participant, schedule, speaker. So we can inject it order creation. So entities, participants, schedules. So things. If it contain a foreign key, then it will give that idea as well. So one to has one with many, one to many relationship here, and these are the basic overall idea to model builder. All right, so we discussed about this event.data, EventScheduler.Data, that data access layer here, that project. Now we are going to discuss about the services, EventScheduler.Services, dependencies, obviously .NET 8 models. So here we can see all the models that here we use the view model, event view model, that can be a later project we call it as DT or something like that. Okay, so you may see here event view model and the new event model looks same, but there are small difference. It's another thing we already know that when we viewing a event, we should pass that ID that will return the event details. But when we creating an event, we don't have ID. That means that ID will be automatically generated by the application. Okay, therefore without ID, other properties will be here, and yes, it's come from inherited from base event model. So these will be we will fix these things in upcoming course. Okay. Right, so required field that will be mandatory like that. Okay, let's see. Yeah, here the same stuff. The participants view models can be DTO, and speaker view models, and services. So here we have an interface, event data service, that can be inherited by event data service concrete class. So normally that we will have use different loosely coupling stuff. We will have interfaces and the concrete class in different classes, but here also this one also fine. When we go for a repository design pattern, then we have a separate interfaces and concrete classes, repositories, services like that. So in event interfaces we just define the method. What are the methods we are going to use? Never implement anything. So just see, normally interfaces give us an idea what are the features our application going to have. So that event data service gives us what are the methods that we are going to create. Add event, add participant, add speaker, delete event, delete participant, delete speakers. So get events and get participants by event. Likewise, these are the method we are going to implement. So it gives an idea. So that is the actual usage of interface. Without interface also we can create the application. That's fine. Alright, so then we are inheriting that interface, giving us the idea that these functions should be implemented, that means should be developed in our concrete class. So we inject our DB context here, that will be deal with the database. So get events, so we are getting the get events by from database, and we are doing a data map here. So we can use automapper sometime, but automapper useful for, it's a library from .NET that we can use to map the database object to a to normal object. Okay, so DTO. But somewhere we need to do some customize whatever the data comes from, we need to do some stuff there. Therefore sometime we go with the manual data binding, okay, directly binding like this. Alright, so these are the stuff. So we are doing some DB context related stuff through this data service, maybe a repository for enterprise level application. Alright, so we have that definition for each explain yes, for each method of these we will we have the implementation here. Alright, so next what we do is we register that particular service, that event data service, to our register method. There we injecting that through an iService collection, iService provider. There we register it to AddScoped method. So we have dependency injection. There we have three type of lifestyle, AddScoped, singleton, and transient. So here we use AddScoped. So that where it will create a new instance for every request, okay, HTTP request. Okay, then it may be unfamiliar sometime. What we do is normally we have the same thing. We normally in the, so what we are doing is here we are registering this inside EventScheduler.Data, and again we in the Program.cs we just register that whole service, build a service, register event scheduler. If we go for so if you see here quick definition, so you can see that register event scheduler service, they are inside the EventScheduler.Service. We injected the service collection there, we register. Instead of that, we can add that directly by menu, directly we can import that as well. Let's see. If you are not familiar this way, the name of the ICE event data, okay. So this is also we can do it directly, but to make a loosely coupling stuff, so what we do is we have registered that in here inside the register event scheduler service. Then we registering that service into the here. All right, so now undo it. Okay, all right, so now this one also done, right? We have injected the service collection. All right, so now event scheduler service is also fine. Now come to our main application where our dependencies and properties, we launch setting, that will be launch the initial stuff of our application. Here we see API monitoring. This will be a initial launching URL, and we enable launch browser true, and environment is development. We can use Swagger UI in future, right? I will come to that part later. And then we have configs. This is the place let's see, I talk about the user identity earlier. So to log in, we should have a user, right? But without defining a user, we can't log in, right? So initial time we seed the data. It's kind of a dummy data that will feed to the our application, that will be used for our identity, and that can be called when we are in just before running application, that users will be seed to our application. And if it does not exist only, it will create. If exist, it won't create again. All right, okay, that's one is here. Let me come to this part. Yes, users can connect return user null only, it will done. Okay, so we can add more users by adding like this. So if it is the user first name is John, then the username and password like this. And if the first name will be Jane, then this is the username and password. All right, that is the next one is the our main part, the controllers. Okay, this base controller that will be initially handle this. If it is not identity invalid, unauthorized, and cannot get user ID. If it is authorized, and it will give us that particular user ID is not matched, and it will return the exception. Otherwise, it will return the user ID. Okay, authentication controller that will consume the particular stuff we already discussed. And yeah, first one is the token generation, and get token and create token. Okay, for that, based on this authentication, username, password, it will check, and based on that, it will issue a JSW validity issuer audience, and expiration duration, and signing credential, and the auth claim. Okay, and it get the secret from the key that will be, we can see here, JWT secret is here, valid issuer and audience. So if this comes from this URL only, this application will allow it, and this secret key it will check. Okay, and yeah, that is fine. Authentication controller. Alright, that logic is there. An error controller, so we do something in upcoming sessions. So we just through a dependency injection, we just creating instance of this, and consume it. So we are adding an event. Here we using a controller. So if that particular event with that will fail, it will return this details, description, name, and the time. Okay, it's hard coded value currently we using. We will fix this soon. And event controller, this is our main controller. The main application core logics will be here. The usual get event, get speaker, find, and posting an event, all this stuff here, and delete function as well. So monitoring controller, so this one will be launched when you calling the first application, that monitoring controller. So that been, so API monitoring, it's a controller name. So API controller name, route monitoring. So here also DB connection checking, this is for our project, but normally we won't have this kind of controller to check whether database is not connected or not. Alright, then participant controller, another important controller where we can add the participants and the delete participant, and speakers controllers that will handle the CRUD function for speaker. We know what CRUD function means: create, read, update, delete. Alright, so this is the stuff. And yeah, so these are the CRUD function for each controller. We see we are not use all this logic in one controller. We have different controllers, different classes. We use solid principles here. That's why you use different kind of solid principle. DI we use interface segregation, we use high level low level differentiation, we have the database access layer separately, and loosely coupling everything with, and single responsibility classes. If you see here, and here also the participants class will contain only the participant related stuff. Yeah, likewise, and we have talked about this. Okay, here we have a model that is used for event scheduler main application, that is only handling the user login model, because other stuff inside the data and the services layer. Okay, so here it's only check for the user login. If it is success, it will allow service layer to give the database to the data to the controller. Okay, that's it. Here username and password, and appsetting JSON and development JSON. So here we have used only the development JSON. If we have production JSON, we will have different kind of environment related settings, therefore we will have separate stuff there. But since we use only one environment, we just have everything inside the appsetting JSON. But in actual project, we will have different connection string for production and then development and other environment. JWT token details also will be different. Okay, the Program.cs, one of the important part. So last session we talk about this enabling or disabling local DB and in-memory DB, and we register event schedule application that we are giving the control to our main application schedule application to inject the service layer, this one service layer, and we adding identity, we talk about this earlier, and authentication, that will check for the default authentication based on the JW token that defined already, and that bearer, it will check for that one, it's saving the token for validation of the session, so it will expire after some time, that we saw earlier. So here we have given that expiration date time. All right, that will be validate that login time. Okay, adding authentication AWT bearer. So if we provide those valid secret and these detail only, our application allow us to validate the user, and yeah, we should allow the controller to use our application, so we just register that, and the app ready to build. Okay, so we provide all the, first we create the app builder, then we provide all the dependencies, and app is built, then we provide if there are any pipelines that we require our application, that we can add. So HTTP request pipeline, what are the things we need to consider when we use a development environment, that may be Swagger UI or other details, because in the development environment we need to show some detail for the development perspective. Let's see that, and then it's a redirection to get the URL correctly, that is user request will be redirect to our application. Authentication, authorization, so authentication giving the access, authorization giving the right access, and let's see if a person has access to the application, but admin, subadmin, those things will becomes under authorization. Seed users will inject the user data, that initial login data. like this, and it will map with the controller. So whatever the URL comes, that will be matched with the controller. So we have seen that initially it's coming launch setting, we use API monitoring, so that will match with that. Then app is run. Now let's run the application. Before that we need to run the Docker image. Okay, but Windows user no need to worry, they can simply use SQL Server directly. All right, let's run the application. Okay, sometime take some time. All right, I've started, build succeeded. Okay, localhost. Okay, now only at the start, actual starting happens. Wait, actually now only it's listening for the request. Sometime we need to use Google Chrome to get the best output. All right, so now connect to the database, true. Let's try to go to a different URL. Error. So what does it give? Nothing is here. All right, let's see.